Good afternoon. Just looking at what we have for the remainder of the test 2 review, and for part 2, okay, we had already looked at the first 4 items, and just for what we have resuming in the case of number 5, okay, and we're looking at determining whether the functions, okay, will be even, odd, or neither, or odd, even, or neither. And we have for number 5, okay, so we have the function given in the form of f of x, okay, where this is equal to x times, okay, the absolute value of x, followed by the addition of 5x cubed. And, okay, so for what we have in this item, okay, so we have with number 5, okay, so we got okay. So again, we have x times the absolute value of x plus 5x cubed. Now, if the function is odd, it's going to be a function where additive inverse inputs will lead to opposite sign outputs. And if you have opposite sign inputs leading to the same output, then the function is going to be even. Okay, so for what we have here, and looking at discovering whether this function is odd or even or neither, and just lining up what we have here. Okay, so you got f of x is equal to x times, okay, the absolute value of x, followed by the addition of 5x cubed. Okay, and if I were to, okay, just completely follow through, now the absolute value of x is going to be x. Okay, so for now we've got x times x. Again, we have plus 5x cubed. And x times x becomes x squared plus 5x cubed. Okay, so this is what we have for f of x. And to see how this output is going to compare to the function whenever the input is negative x. Okay, so if I fill in negative x in place of x, okay, so where I had x times the absolute value of x, so I'm now looking at negative x times the absolute value of negative x. And we have plus 5 times the cube of negative x. Okay, and just looking at what we have now. Okay, so again, we had the absolute value of x to be x. And guess what? The absolute value of a negative term is going to be a positive as well. So the absolute value of negative x is going to also be at x. And so for what we have in the follow through, okay, so we got negative x on the outside. Okay, so you have negative x times x, and we have plus 5. Times the cube of negative x, that's going to be 5 times negative x cubed. And for what we have for this final output, so you have negative x times x. Okay, so this will be negative x squared, and 5 times negative x cubed. So we're going to end up at minus 5x cubed. Okay, so looking at what we have in the development. Okay, so we have for x and negative x. Okay, so the inputs are additive inverses. Okay, so they are opposites. And if you look at the output terms. Okay, so you have x squared and negative x squared. Also for f of x, we have included in the output, we have 5x cubed, whereas for f of negative x, we have minus 5x cubed. And so we have the outputs to be unanimously opposite each other. Okay, and from this case, since everything is opposite in the output, as we apply additive inverse inputs, it turns out that our function f of x equals x times the absolute value of x plus 5x cubed. Okay, that is going to be an odd function. Again, had we had the same output throughout, we would have had an even function instead. Now, for what we have in the case of number 6, so we have a function g of x is equal to 2 over x plus 3. Okay, so looking at how g of x is going to compare with g of negative x. Okay, so you have g of x is equal to 2 over x plus 3. And in the case of g of negative x, okay, only one adjustment here. So you have 2 over, instead of x plus 3, we're going to have negative x plus 3. And looking at what we have among the components. Okay, if you notice, we have with the numerator as well as the number 3. Okay. These values are the same. Okay, however, in the case of what we have with x and negative x, okay, so these will be opposites. Okay, and if you have the output, okay, the coexistence of same terms along with opposite terms. Okay, in other words, there's a mixture of the same as well as opposite in the output. Again, you have a bit of static that is created. So if you had all opposite, g of x would have been an odd function. And if you had everything to be the same, like if g of negative x also came out to 2 over x plus 3, this would have been an even function. Okay, but for what we have instead is that g of x happens to be neither of the two cases. All right, now for what we have in the case of item 7, okay, so this time we have a cubic root function, okay, where we have h of x is equal to the cubic root of x cubed plus 5x. And for what we have in the case of h of x, okay, just restating, so you have h of x is equal to the cubic root of x cubed plus 5x. And see how this is going to compare once we get to the output, okay, for h of negative x. Okay. So again, you have h of x is equal to the cubic root of x cubed plus 5x. Now for h of negative x. Okay, so you have the cubic root. Now for x cubed, okay, this will be the cube of negative x. Plus 5 times negative x. And so for what we have here, the cube of negative x, okay, so this will be negative x cubed. And 5 times negative x, so this will be minus 5x. Now looking at how the outputs will compare. Okay, so you got the cubic root of positive x cubed and plus positive 5x, and the cubic root of a positive is going to be a positive, whereas in the case of what we have for h of negative x, we have the cubic root of negative x cubed minus 5x, and the cubic root of a negative is going to be a negative. So just sort of lining up what we have here. Okay, so these are opposite. And again, we have opposite sign outputs emanating from whenever we apply opposite sign inputs. Okay, and so we have in this situation, since we have opposite signs throughout, okay, this function h of x winds up being yet another odd function. Right. Now, for what we have in the case of the next item, and we have with reference to the graph below, okay, and there are separate sections involved. Okay, and it says that for the graph below, okay, it says to determine the domain and the range. Then we have the relative maxima and minima, and also where the relative maxima and minima will occur, and also the intervals for g of x is strictly increasing, as well as the intervals where g of x is strictly decreasing. Okay, so like once we get into chapter 2, we'll be going more into domain and range. Now again, domain will be in reference to the values we have in x, whereas range will be in reference to what we have in y. So just looking at what we have in the graph itself. Okay, and so we have at least in the case of x, now we have just with the pointing arrowheads. Okay, so we got so you have the direction, so you have going up and to the left, and you can just say that horizontally, at least on the side of x. Okay, we have approaching negative infinity, and with the other arrowhead, we have indicating going horizontally out to the right. Okay, whereupon we are looking at approaching infinity. And so we have, so if you were to read the graph in order from left to right, okay, so you have from negative infinity, and as you have non-stop motion to the right, and guess what? You have, in the case of x, you're looking at whereupon the domain is going to be the set of all real numbers. Okay. Now, in the case of the range, okay, now for the range, okay, you're going from the smallest y value to the largest, okay. Okay, so you have just with the arrowheads, you have pointing upward. Okay, so for the positive infinity, in this case, right, so you had that y approaches infinity, And for what we're going to have in the case of the minimum value for y. Okay, so if you notice, okay, we have with this point, okay, so y is not going down continuously. So you got your minimum y value at -5. Now for the range, okay, now you got -5 and we have a solid point here. So -5 is going to be included. So you have this in the bracket. And again, the maximum y value. So you're going from the smallest y to the largest y. And the largest y is going to be tending to infinity. Whereas with what we had in the case of x, you're looking at the smallest x value, or in this case the leftmost at -infinity, and we have continuing moving to the right where that is going to be approaching infinity. So that will be the respective domain and range, okay, for this particular function that we have in y is equal to g of x. All right, and see what we got here. That is correct, -5 to infinity. Very good. Okay, now we have in the case of looking at where the relative minimum and maximum will occur. Okay, and just we have with the categories. Again, just kind of doing a little bit of a refresh with the same graph. Okay, so in the case of what we have with our points, okay, so again, relative minimum, okay, this is where you're going to have bottoming out. We have like a decrease is followed immediately by an increase. And for what you have for the next point, okay, you have this as a peak location where you have an increase is immediately followed by a decrease. And we have with the remaining points before the graph continues to go up, okay, we have another bottoming out. Okay, so this is going to be yet another relative minimum. Okay, and for the relative minimum values, okay, those are going to be your y coordinates. Okay, so if you notice, you have for the first point, okay, this is going to be a minimum, and the coordinates now we have -1, -5. So the relative minimum value here is going to be a y at -5. And the other minimum value, okay, the location we have at 4, -2. So you have the y value at -2. And in terms of where the relative minimum will occur, okay, those are going to be the x values. Okay, so again, when we have y at -5, the corresponding x value was at -1. And whenever we have y at -2, okay, we had the corresponding x value was at 4. Okay, so your locations have -1, -5, and 4, -2. And again, the y values will be where we had the minimum as well as the maximum. And for the relative maximum, okay, there is only one location, and this is where we had the ordered pair at 2, 1. So the maximum in this case is going to be the y value So that is going to be at 1. And in terms of where that point exists, okay, this would be where we have the x coordinate. So whenever y is at 1, okay, we're going to have the x is equal to 2. Okay, so there's only one relative maximum and two relative minima. Okay, so again, the relative minima and maximum refer to the y values, and in terms of where they occur, this is addressing the x values. Okay, now with the same graph, okay, where we are looking at the activity where we have increasing and decreasing. Okay, and you'll be looking at reading in order from left to right. Okay, so we have okay, so reading from left to right. So you have for the first part here, okay, you have a decrease. You have between the next set of points between the first minimum and the only relative maximum that occurs. Okay, we have an increase. Okay, we have followed by a decrease. And again, we have for the rest of the activity, okay, we have an increase. Okay, and just specifying the intervals. Okay, so you have weather activity. Okay, now again we have just with the continuous motion. Okay, so the minimum x you have tending to negative infinity, and the maximum x value you have tending to positive infinity. Okay, now for what we have in the first bit of activity, okay, reading from left to right, okay, so you have a decrease. So you have between x from negative infinity and approaching the first relative minimum location. This will be where x is at -1. And again, for the decrease and the increase intervals, okay, we're going to maintain the use of parentheses. Okay, so the first activity, we have the decrease. So we have between negative infinity and -1. And then for the next mode of activity, okay, we have a strict increase, and that is between -1 and 2. And then we have followed by a decrease. Okay, and so that's between x at 2 and x at 4. And again, with increases and decreases, okay, we maintain the use of parentheses. And then for the rest of the activity, okay, throughout, okay, we have a continuous increase, and this will be once we get past x at 4. Okay, so starting out between negative infinity and -1, you have the decrease. Then you have between -1 and 2, you have increase. Next, you have between 2 and 4, a decrease. And again, for the rest of the activity, we have an increase. All right. And now, for what we have in the next portion, and we have concerning functions and operations. And okay, so we're looking at least for the first portions, okay, we are looking at specified inputs. And okay, so for this set of functions, okay, the first item, we're looking at g plus h of 5. Okay, so you have the sum function. We have g plus h of 5. Okay, and this will translate as the sum of the functions g and h, okay, where the input is going to be at 5. Okay, so we're looking at g of 5. Plus h of 5. And we have our functions g and h defined, okay, above. And looking at what we have for what we have in the case of g of 5. Okay, so if I had to specify the numerical value. So for g of 5, we're looking at g of x equal to x minus 7. And with x at 5, we have g of 5 is equal to 5 minus 7, which is going to be negative 2. And for h of 5, again, referencing h of x, so that is equal to x squared plus 5. So you have 5 squared plus 5. 5 squared is 25. And we have 25 plus 5 is equal to 30. Okay, and with the values of g of 5 and h of 5 now determined, okay, we can go ahead and fill in. So we have with g of 5, okay, so we have negative 2. And you have plus h of 5, which is going to be 30. And we have for the final output, we have negative 2 plus 30. Okay, so this will come out to 28. Okay, now for what we have in the case of number 9. Okay, so we're still working with g and h, but this time we have h minus g of 7. Okay, so we're now going to have h of 7 minus g of 7. Okay. Again, just referencing what we have for h of x. Okay, now with the input at 7. Okay, so for h of 7, okay, you have 7 squared, which is 49. And then adding 5, so in this case, like when x is 7, your y value is going to be h of 7, which will be 54. And for what we have in the case of g of 7, okay, so for g of 7, okay, again, we're referencing x minus 7. And 7 minus 7 is equal to 0. So we have in following through, so you have h of 7 is at 54. You have minus g of 7. Okay, so we have g of 7 at 0. And we have 54 minus 0 at 54. Okay, now for what we have in the set, now we're crossing over to multiplication. So we have this time we have g times h of 5. Okay, so you now have g of 5 times h of 5. Okay, so we got g of 5 and h of 5 all over again. Again, for number 8, okay, we already attained those particular values. Okay, so again, g of 5 is going to be at -2, h of 5 is going to be at 30. And just filling in, okay, so you have -2 times 30, and we have for the output, okay, this will end up at -60. All right, now for what we have in the next portion, okay, we're looking at quotients of functions. Okay, so you have f over g of 2 and g over k of 0. Okay, so you have with f over g of 2 okay, so we have f of 2 over g of 2 okay, and for what we have in this case, right, so this is our first use of f. Okay, so for what we have in the case of f of 2, okay, so referencing f of x, okay, so again we have f of x is equal to 3 over x plus 4, and we have with the input at 2, so we have 3 over 2 plus 4. So you have 3 over 6, and 3 over 6 reduces to 1/2. And for what we have in the case of g of 2, okay, so you have g of 2 is equal to 2 minus 7. So this will be at -5. So for what we're going to have in the ratio, okay, so you got f of 2 is at 1/2. G of 2 we have at -5. So you have a fraction between a fraction and an integer. Okay, so just kind of spreading things out a bit. So you have 1/2 divided by -5. Again, we can follow through. Okay, so again, you think of -5 as a fraction. Like -5 over 1, and dividing by a number will be the same as multiplying by that number's reciprocal. Okay, so in this case, we're going to have 1/2 and division by -5, okay, that would be the multiplication by the reciprocal, which we have at -1/5. Okay, and so we're going to end up, okay, so 1/2 over -5 becomes 1/2 times -1/5. Positive times the negative is a negative, and you're looking at the negative of 1/2 times 1/5, so we end up at -1/10. Now, in the case of what we have with number 12, so we now have g over k of 0. Okay, so we have g of 0 all over k of 0. Okay, and again, just putting in the values. Okay, so we got for g of 0, okay, so referencing g of x, okay, and with x at 0, so g of 0 is equal to 0 minus 7, which would be negative 7. Now for k of 0, okay, so this is our first entry of k, and k of the input is equal to the square root of the input plus 9. So 0 plus 9 is 9, and the square root of 9 is equal to 3. And with g of 0 and k of 0 both determined. Okay, so again we have g of 0 at negative 7. We have over k of 0, okay, which we have at 3. Okay, so that'll be your answer, negative 7 over 3. Okay, so that is going to be negative 7/3. Right. Now, crossing over into what we have concerning compositions. Okay. Okay, so you had the value of x, okay, to be at 3. Okay, so we have, in the case of number 13, and so I'll just start out with the compositional notation. Okay, so you have f composed with g of 3. Okay, so again we have f of g of 3. Okay, now your output function, okay, is going to be contingent upon what the outside variable is. In this case, we'll have that to be f. Okay, so we're going to be referencing f of x, whereupon we have f of the input is equal to 3 over the input plus 4. Okay, so you have this time around, okay, in the compositional setup, okay, so the input is now g of 3. Right. Now, we got 3 over g of 3 plus 4, okay, and we can determine what the value of g of 3 is. So here we have g of 3 is going to be 3 minus 7, which would be at negative 4. Okay, so again, we have f of the input is equal to 3 over the input plus 4. Input, we have at g of 3. Numerically, g of 3 is equal to negative 4. And so, putting in, say, have negative 4 for g of 3. So we now have at this stage, okay, we have 3 over negative 4 plus 4. And guess what? We have negative 4 plus 4 at 0. And guess what? Since we have 0 on the bottom, we have within the real number system, okay, the fractions can be defined only if the denominator is not 0. But since we have a 0 denominator, it turns out that we have no solution, and in this particular composition, we end up with an undefined expression. Okay, so f composed with g whenever x is 3, okay, this ends up becoming undefined. Now, if I switch the order of the variables, okay, whereupon I have g composed with f of 3, okay. Now before, the output function was in line with f of x, but now switching the order, the output function will be in line with g of x. So again, we have g of the input is equal to the input minus 7. Okay, so in terms of what to do with g of f of 3, so this time the inputs we have f of 3. Okay, so we have f of 3 minus 7. Okay, and we can now evaluate f of 3 okay, so for f of 3, okay, we have f of 3 is equal to 3 over 3 plus 4. And so this will come out to 3/7. Okay. All right. And so taking that over and following through with this particular composition. Okay, so we have 3/7 minus 7 and we just follow through in case you have, we got 3/7 and 7 you can write as 7 over 1. Okay, so I can write 3/7 minus 7 as the difference between 7s. Okay, so for 7 over 1, okay, that's going to be 49 over 7. Okay, so we'll have 3/7 minus 49/7. So for this particular composition, okay, this one is going to be defined, but it's going to be with a negative non-integer value, where we end up at negative 46/7. Now, looking at what we have for the next items, okay, so this is where we have domain to come in. So we're going where we had 8 through 14 to be specific cases. We're now looking at the general cases, okay, where we are now looking at finding out the domain. Okay, and first of all, we have f composed with h of x. All right, so you have f composed with h of x. I'm trying to find out, okay, just what the domain is going to be. Okay, so having this setup, okay, so you have the output function in line with f. Okay, so you have f of the input is equal to 3 over the input plus 4. Now, in reference to this composition, okay, so the input, not x, but h of x. Okay, so 3 over h of x plus 4. So you got h of x is x squared plus 5. And we have in the follow-through, okay, so we have for this composition, okay, so we got 3 over. Now we got x squared, which is the only variable term we have in x. And then we have plus 5 plus 4, so this will end up at plus 9. Okay. So this will be a resulting composition. Now, in the case of the domain, okay, so you're looking at keeping the input function and the resulting composition defined within the real number system. Okay, so you have the input is equal to h of x, okay, which we have at x squared plus 5. Okay, and since we don't have a fraction or an even root radical or anything that creates an undefined situation, okay, we have for h of x, okay, this has no restrictions. Okay, now for the output itself, okay, now we got a fraction, and we have 3 over x squared plus 9. Now, if there were any restrictions, okay, it is to keep x squared plus 9 from becoming equal to 0. So again, we want to avoid a 0 denominator. Okay, so you have x squared plus 9 cannot be 0. Okay, now I cannot factor x squared plus 9 into real terms exclusively. Now I could with the difference of squares. If I had x squared minus 9, I would have the factors of x plus 3 and x minus 3. But with x squared plus 9, what I can do is I can just move the 9 over. So I have the x squared cannot be negative 9. And if I go with the square root property of equality, okay, we have going from x squared to x, we have the x cannot be plus or minus the square root of negative 9. And guess what? We have for plus or minus the square root of negative 9, we have plus or minus 3i. But guess what? Positive and negative 3i, okay, come from the complex number system. So in this case, okay, so we got complex numbers. Okay, so plus and minus 3i, those are complex numbers. So you have no real values excluded. So you can plug in anything from the real number system and have this ratio to be defined. It could be 0, it could be positive, it could be negative for what we have in x. So since there are no real values excluded, that means just like the input, the output has no restrictions. All right, so between the input and the output, okay, we have no restrictions at all. So this means in consequence, okay, that is that for this particular composition, we're going to have the domain to consist of all real numbers. Okay, now for what we have in the case of number 16, okay, we have for this next composition, okay, so we're looking at G composed with K of X. Okay, so we now have G of K of X. Okay, so for G composed with K of X, again, we'll have the output function in line with G of X. Okay, so G of the input is equal to the input minus 7. Okay, so for what we have in this particular instance case, so we have the input is K of X. Okay, so G of the input minus 7. And with K of X, okay, so you have the square root of X plus 9. We have followed by the subtraction of 7. Okay, so we have the square root of X plus 9 minus 7. This part is going to be the final output. Now, for what we have in the case of restrictions, okay, so you have the input is equal to K of X, which is equal to the square root of X plus 9. And in terms of any restrictions, okay, because we have an even root radical, again, we cannot have X plus 9 to be negative. Okay, But now the square root of x plus 9, you can have x plus 9 to be 0 or positive. Okay, so if x plus 9 is greater than or equal to 0, and if x plus 9 is greater than or equal to 0, we're going to have the restriction for the input to be that x is greater than or equal to negative 9. And again, we have for the output, so again we have the square root of x plus 9 minus 7, and again the offsetting pattern is just going to occur with the square root of x plus 9 term. So it's going to turn out that both the input and the output will have the very same restriction. Okay. So between the input and the output, okay, we have the only restriction that exists is going to be that x is greater than or equal to negative 9. So in the case of the determination of the domain, and we have with the value of interest case, you have negative 9. And we have, thanks to the equal sign, negative 9 is included. All the other values in the domain will be greater than. And in graphing terms, okay, we have represented by the ray going continuously out to the right. So for what we have in the case of 16, it's going to turn out that for the domain, okay, so we're going from and including negative 9 all the way out to positive infinity. Okay, all right. Now, for what we have in the next item, okay, we have for number 17. Okay, so we're looking at the domain of the sum of f and k of x, as well as in number 18 where we have the domain of the quotient where we have f over k of x. Okay, and you can look at, especially number 17, you can look at this through either of a couple of ways here. Okay, now remember, the sum difference and product functions, okay, will have the same domain. Now just kind of a backdrop here for number 17. Again, we have with f of x, we have is equal to 3 over x plus 4. Okay, and again, just for the restriction upon f of x. Okay, now we cannot have a 0 denominator. So we have the x cannot be negative 4. Okay, now for k of x, So k of x, okay, we have the square root of x plus 9. Right. Again, we just dealt with k of x in the composition. And again, to keep x plus 9 from being negative, okay, we had that x is greater than or equal to negative 9. So that's a restriction for k of x. Now, for what we have, again, we have f plus k of x. And we have f minus k of x. Then we have f times k of x. And just restating, okay, so these three operations are going to have the same domain. Right. And for the sum difference and product functions, okay, so I need to be able to work with both f of x and k of x. Okay, so be able to work with f of x. Again, x cannot be negative 4. And to be able to work with k of x, okay, at least x must be greater than or equal to negative 9. Okay, so you got these two sets of restrictions, okay, and to keep both conditions, that is, the conditions for f of x and k of x satisfied. You can see what values of x, okay, can keep both f of x and k of x defined throughout the operations of addition, subtraction, and multiplication. So just looking at what we have from a visual perspective. Okay, so we have, in the case of the numbers of interest, okay, so you have negative 4 excluded, and you also have negative 9, which we have as a lower limit. Okay, so negative 4 is not included, so this isolated value, again, is left out, so you can symbolize this with an open circle. Now, in terms of conjoining with what we have with this other restriction, say if x is greater than or equal to negative 9, so negative 9, that is included, and all the other values you had to be higher than negative 9, so you would proceed with activity going out to the right. But again, with negative 4 left out, okay, we have to pause just a moment. Okay, so this would be the first bit of activity that will satisfy both f of x and k of x. And once we get past negative 4, then we have the formation of the rest of the elements that will define the domain of not only the sum but also the difference and the product of what we have between f of x and k of x. So we have in this particular case, right, so for the sum difference and product functions, okay, now you'll have for the domain, and reading in order from left to right, okay, so you have going from and including negative 9. Negative 9 is included, so this will be in the bracket. And you have moving out to the right, approaching but not including negative 4, thanks to the restriction imposed upon f of x. So negative 4 is going to be in the parenthesis. And bypassing negative 4, okay, we have the rest of the domain to be those values of x greater than negative 4. Okay. So for this item, okay, we have for the sum difference as well as the product function. Okay, this is going to be the domain of what we have expressed in interval notation. All right. Now, in the case, again, so the sum difference and product functions will have the same domain. Okay, but now with the quotient function, okay, this can have a domain that is distinct from these three operations. Okay. So in the case of number 18, okay, this one's a little bit tricky too. So we have for f over k of x, okay, so we have f of x over k of x. Now again, f of x is a fraction. So you have 3 over x plus 4. And we have divided by k of x being the square root of x plus 9. Okay. And undoing the ratio between this fraction and this radical. You're just kind of splitting this up. Okay, so you have 3 over x plus 4. Is divided by the square root of x plus 9. Again, if I divide by a term, it'll be the same as multiplying by the term's reciprocal. Okay, so dividing by the square root of x plus 9, so we'll have multiplying by the reciprocal, we're going to have 1 over the square root of x plus 9. So multiplying together. So got the constant 3 in the numerator, whereas in the denominator, we'll have two variable expressions. Okay, so we have the quantity of x plus 4, and we have times all of the square root of x plus 9. Okay, so there'll be some things to sort of alloy together. Okay, first of all, okay, we have x plus 4 is in the denominator. Okay, so you have the x cannot be negative 4. Okay, now in the case of what we have with the square root of x plus 9, okay, because we have a radical again, x plus 9 cannot be negative. And because x plus 9 is also in the denominator. Okay, we have the x plus 9 cannot be 0. Okay, so again, okay, anytime you have an even root radical in the denominator position, again, what you want for the expression inside the radical Okay, you want that to be positive. Okay, so x plus 9 must be positive. So putting what we have in inequality terms. Okay, so you have x plus 9 is greater than 0. And so we have that x is greater than negative 9. So keeping everything intact within the real number system for this particular quotient function. Again, we have trying to satisfy simultaneously that x cannot be negative 4, while also we have the x is greater than negative 9. And looking at arriving at the domain. Okay, so we've got negative 4 and negative 9. Okay, so we have regarding negative 9, so you have x is greater than negative 9, so negative 9 is not included, so you have an open circle. Negative 4 also not included. For the other values, okay, you have x is greater than negative 9. Okay, so we have activity to the right of negative 9, and again, approaching but not including negative 4. Thanks to the restriction that was placed upon f of x, and then we have bypassing negative 4. Okay, we can resume, okay, again with array moving continuously to the right. And so we have in the case of the domain of this quotient function. Okay, so reading in order from left to right, so we have negative 9, and since that is not included, okay, we have this in the parenthesis, and we have approaching but not including negative 4, so we apply close parenthesis, and bypassing negative 4, and for the rest of the values we have in x, okay, so you have those amounts greater than negative 4, and with infinity being boundless, we have the exclusive use of parentheses. Okay, so this would be the domain of what we have in the case of the quotient function. Okay, and almost like what we have with the sum, difference, and product functions. However, with the square root of x plus 9 being in the denominator position, we can no longer have negative 9 included in the domain. And now just some items we have, and just referencing what we have encountered in the case of the composition of functions and their domain. Now, for what we have in reference to number 17 from the first part. Okay, so you've got two functions, f of x and g of x. And we're looking at the domain of these operations occurring between f and g of x. Now for the first three functions, you got the sum, difference, and product functions. Those are going to have the same domain. Okay, so for the setup in number 17, okay, at least for the sum, difference, and product functions. Now, for f of x, okay, we have 3 over x minus 1. Again, the restriction upon f of x is going to be that x minus 1 cannot be 0. So for f of x, we have that x cannot be at 1. Now for g of x, now we got x over x plus 12. Again, the denominator cannot be 0. So if x plus 12 cannot be 0, then we have that x cannot be equal to negative 12. Now for the domain of the sum, difference, and product functions, again, all of these are going to be the same. Okay. All right. Again, to keep f of x defined, and the x cannot be at 1. And also to keep g of x defined, we have the x cannot be negative 12. So we have two values left out. And in terms of graphing, you would have just open circles on negative 12 and 1. And for the domain, it'd be all the other values, okay, before and after and in between negative 12 and 1. And so now for the domain, okay, so again, if I were to rank order from smallest to largest, okay, so for the domain, okay, so you're going from negative infinity, approaching the smaller of the excluded values. In this case, so that's going to be negative 12. Okay, so again, negative 12 is excluded, and we're looking at bypassing negative 12. And approaching the next excluded value, which is going to be 1. And since 1 is the next and only remaining excluded value, we have for the rest of the domain, okay, we have those values of x greater than 1. Okay, and so again, that is going to be for all of the sum, difference, and product functions. And again, we have with the quotient function, okay, that can have a distinct domain. And just looking at what we have here now for f over g of x. Okay, so you have f of x over g of x. Again, we have with f of x, we got 3 over x minus 1. And for g of x, again, we have x over x plus 12. Okay, and so you have a ratio between fractions. And again, just to get out of this particular ratio mode. Okay, so you got 3 over x minus 1. And we have divided by x over x plus 12. And again, dividing by a fraction will be the same as multiplying by the fraction's reciprocal. So we have this time x plus 12 is at the top and x is on the bottom. And we can leave this in factored form. So we have 3 times the quantity of x plus 12. And so we have all over x times the quantity of x minus 1. Now in terms of what we have for the restrictions, again, we had f of x over g of x, so this is our f of x. Again, x minus 1 cannot be 0. Once again, we had the x cannot be at 1. And again, for g of x, again, we had x over x plus 12. Again, we cannot have a 0 denominator. So again, we have that x cannot be negative 12. Now, where we have the quotient function to sort of drift away from the other 3 operations in terms of maintaining the same restrictions, we now have, upon taking the reciprocal of x over x plus 12, we now have x on the bottom. So now, not only do we have 1 and negative 12 excluded, we also now have that 0 is left out. Okay. So for the quotient function, again, we have x cannot be 1, x cannot be 12, and x cannot be 0. So we have with our values of interest case, we have negative 12. And then the next excluded value we have 0, and also we have at 1. Okay, and for what will be in the domain will be all the other values. So we have with the added exclusion of 0, okay, we're going to have a longer interval notation for the domain of the quotient function. So this time we have between negative infinity and negative 12. And then we have between negative 12 and 0. But not including those values. Okay, then we have going past 0, approaching, and not including 1. And for the domain remainder, okay, we have those values of x, okay, which we have to be greater than 1. So this will be the outcome of what we have with the quotient function. Okay, now, and this will get analytical once we look into the compositions domains. Okay, so for f composed of g of x and g composed with f of x. Okay, so for f composed of g of x, so we have f of g of x. Okay, now we're going to operate in line whereupon the output function, okay, is with respect to f of x. And again, f of the input is equal to 3 over the input minus 1. Now we got the input at g of x. And just filling in, okay, so for what we have for g of x, g of x, you have a fraction, so you had x over x plus 12. Okay, so we have a bit of a complex fraction, so you got 3 all over x plus 12 minus 1. And what I can do is that I can get out of the complex fraction mode. Okay, if you notice, we have between the numerator and denominator. Okay, we have one fraction, and that is with x plus 12 as the denominator. And what I can do to kind of clear up the notation is to multiply this ratio by 1 in the form of x plus 12 over itself. Okay, and for what we have in this arrangement, okay, so we have with the numerator, okay, so we got 3 times, okay, the quantity of x plus 12. So what I think I'm going to put this in red. So you got 3 times the quantity of x plus 12. Now for what I have in the denominator, so you're going to have both of these terms multiplied by x plus 12. Okay. So now we've got 3 times the quantity of x plus 12. Now for what we have in the denominator, okay, so with the distribution of x plus 12, okay, multiplying by x over x plus 12, and get this set to go out, leaving us with x. And then we have with the other distribution, so we have negative 1 times the quantity of x plus 12, so this will be a negative x and a negative 12. And if you notice, we have with the variable terms in the denominator, okay, so x minus x will go out. Okay, now for 3 over negative 12, okay, so you have 3 over negative 12, so that'd be like 1 over negative 4. Okay, so you have x plus 12 over negative 4. Now, looking at the restrictions, again, we have the input. We have it g of x again, that was x over x plus 12. Again, for the restriction for the input, again, we have x plus 12 cannot be 0. So we have that x cannot be negative 12. Okay. Now for x plus 12 over negative 4, okay, now we got a fraction, but since we do not have variable expression in the denominator, we say that in this case for the output there's no added restriction. All right, so for what we have for this composition, okay, so we're going to have the only restriction is going to be that x cannot be negative 12. Okay, so for the domain of f composed with g of x, okay, so we're leaving out only negative 12. So we have for the domain, you have those values of x less than negative 12, along with those values of x greater than negative 12. And for what we have in the case of the reverse order, we have with this remaining problem, okay, so we have with g composed with f of x. Okay, so you have g of f of x. Okay, now the output function, again, we have in line with g of x is equal to x over x plus 12. Okay, now with the input at f of x, okay, so you're looking at f of x all over f of x plus 12, and for f of x, again, we had 3 over x minus 1. Okay, so you have another bit of a complex fraction, not as in the letter I or the square root of negatives, but we have a ratio between fractions. And in this one, okay, we have between the ratios, okay, we have the numerator fraction has x minus 1 at the bottom, likewise with the fraction in the lower part of the ratio, we have x minus 1 in the denominator. So what I can do here is clear out at least the fractions, multiplying by 1 in the form of x minus 1 over itself, kind of like what I did with x plus 12 over itself whenever we had f composed with g of x. Okay, so just looking at what we have in the development here. So I'm just going to take this one sort of added step. And we'll distribute the lower x minus 1 over the two terms in the denominator. All right, so for what we have in following through, okay, so you got for the numerator part, okay, we have x minus 1 is going to go out, so this leaves us with 3. Now for what we have in the denominator, okay, so I have x minus 1s will go out. So you got 3. And then we have 12 over x minus 1. So we have it 12x minus 12. So this will come down to 3 over 12x. And 3 minus 12 is going to be negative 9. And guess what? I can lower this. So you have for 12x minus 9. You have 3 times the quantity of 4x minus 3. And we have for the final output, okay, so that's going to be 1 over 4x minus 3. Okay, so we have, in this case, right, so we have looking for the restrictions. Okay, so we have with the input, okay, so you have f of x is equal to 3 over x minus 1. And once again, we have further restriction. X minus 1 cannot be 0. So we have the x cannot be 0. Now for the output, okay, so I have 1 over 4x minus 3. And we got a fraction. This time we have an x term in the denominator. So the restriction is that 4x minus 3 cannot be 0. And if I try to solve what is excluded from x, so if I were to add 3 to both sides, we had that 4x cannot be equal to 3, and we have with division by 4, turns out that we're going to have that x cannot be equal to 3/4. Okay, so we now have combined exclusions this time around. So we have for the restrictions, okay, so we have the x cannot be 0, and the x cannot be equal to 3/4. And now we have with the excluded values. Of 0 and 3/4. Okay. And again, 3/4 is between 0 and 1, but a bit closer to 1. So 3/4 is left out, 0 likewise. And looking at what will be in the domain, we have all the other values. Okay, so for the domain of G composed with f of x, okay, so you have those values, okay, less than 0, and then we have followed by those values between but not including 0 and 3/4. So maintain the use of parentheses, and for the rest of the values, okay, you have those values of x which will be greater than 3/4.